So now in this video, I thought we would take a closer look at the voltage booster module that I have right here. So these ones you have to solder on the wires, but I bet I only paid, around $1 for these. Maybe if I bought them a long time ago it was a little bit more, but now I think they're down to like $1, maybe $2, and you probably get nicer ones for like $3. Boosters are not terribly expensive, depending on how cheap you want to get. And so I'm just taking the probes here. Again, for, I soldered those wires. They look pretty bad because I had an old oxidated soldering iron tip, and that motivated me to get new tips and also learn how to tin them better so that they don't oxidize. But there we go. I just screwed down the probes for the multimeter. And one tip before you insert one side or the other, by the way, this black wire was loose when I started here. And I repositioned it, the little screw down there. It's flat on the bottom, but it's not terribly wide. So it was intended for larger wires and for using ferrules, which are larger than the base wire. But yeah, there we have it. Now, the power supply is off right now. It's not even connected to the module, so we're not going to get any voltage. And it says negative V in over there, positive V in over there. The positives are across from each other, the negatives are across from each other. And so pretty simple there. And I can clip to this part. So last video I had a micro USB plugged into there, and these share the same voltage. So I was able to measure that. And yeah, actually I forgot. This power supply, when it's off, it actually provides a negative voltage. And so I think it would be 0.6 volts, but some of it's going into the board. So that's something to be aware of if you have this power supply and they haven't fixed it. So now I'm going to 5 volts. I only got 20 milliamps of current because there's no load. So I set this to about, there we go, voltage booster, to about 15 volts for my earlier video. I was lighting a light that works at between like 12 and 24 volts. And I think you can go up to 30 though. That's the max of this power supply. And it didn't fry it when I just had the light directly to the power supply. I was using a 5 volt power supply when it came to this unit. It only provided 5 volts, so I needed the boosted voltage for that light. But yeah, it's pretty simple right there. 5, 15. And this is not digital. Again, if you want to shoot for like the dollar ones, you're probably going to be limited to an input and output of about an amp. It'll probably say like 2 amps or something. And, and then you won't be able to program it. You'll have a little trim pot right here. So multi-turn trim pot. But there you can see, it looks like counterclockwise. That raises the voltage right there. Or no, now it's going down. I thought it went up for a little bit. So that's counterclockwise. Now let's go clockwise right there. So yeah, you want to go slow. It's multi-turn. You can turn it many, many times. And I don't remember the maximum and minimum voltage to this. I always pay close attention. But obviously this one must have been one of the lower end minimums. A lot of them you can get down to like 3 volts. So I bet this is like a 3 to 30 volts in, and then maybe like 5 to 32 volts out or something like that, I'm guessing. So yeah, you get kind of a feel for what the range of these will be when you look at a lot of the sales. But I haven't, people selling them, but I haven't looked in a while. But yeah, it's really that simple. Just remember, right now we got like 20 milliamps there. This is 5 times the voltage there. So we would only get, maybe if we're lucky, 4 milliamps out. This isn't the perfect conversion. So you got that higher voltage coming out, but that means your supply voltage, which is at a lower voltage supply source, has to provide a multiple amount of current to get a fractional amount of current out. So you're converting current for voltage. But I'm not going to raise this and do a test. There you can see we set it to 25 volts. It's that simple. And then also, I believe in setting it at about the lowest voltage you can. And then now I'm gonna, it may not be a good idea to jump real quickly. Maybe a sudden voltage shock might affect this. But there you can see. Now we got like a 15 volts. So whatever current we had to provide before, it's not registering it, it's so little just to get this voltage, but whatever current we had to provide to power a load, since now we increase the supply voltage by 3 times, the current that it has to provide will probably go down about 3 times approximately. So I showed that in a recent video, so we're not going to dwell on that too much. Just wanted to show how easy it is to work with these voltage boosters. And I should set this back to 5 volts. Generally I keep it at 5 volts because I mostly use circuits with 5 volts. So I don't want to wire up a circuit meant for 5 volts and then accidentally apply a higher voltage because I set that higher thinking it was 5. But yeah, the holes here, you can run a wire through them. That's what I did there. And then I got the solder. Again, they're big blobs because my iron wasn't very good. I had to get a big blob on the thick part of the iron and work its way down. It was oxidized. Now I got new tips that I tinned, and the solder flows much better. But yeah, other ones have another screw down. Like I said, this has a screw that spins down onto the wire. Usually the bigger modules have a nicer screw down where the screw just pushes like a little metal plate down, so it makes a much better connection. But these are cheap connectors. Again, you get higher quality the more money you spent, but don't waste your money. Get as high quality you need at the price that you want. So yeah, that's really about it. I make voltage booster circuits. I think they're really interesting and really cool. When I first started learning about them, I planned on making voltage boosters, but then I started noticing they're really cheap online. Even just buying all these components and stuff, it's probably gonna run you to the same price as the board. So might as well just get a pre-made one that probably works. Every once in a while you get one that arrives not working, but for the most part they work. Whereas if you build one yourself, probably not going to work right away. You're probably going to have to fix it. It's just that easy to make mistakes. They make less mistakes in a factory where they just keep cranking these out. But yeah, simple video today, but again, important topic. Most of my videos are, circuits where I put components together and everything, and, show how the circuits work. But generally, in electronics, you're probably not going to be at that level where you're building your circuits. You just buy modules that do what you want to do and wire them up. You may have to replace a component on there or something, or troubleshoot the module, something like that. But the vast majority of the time you buy a module, it will probably work. If it doesn't, you probably replace it with another module and so on. But it's still good to know the basics. And, I think electronics is interesting, so I like learning about them. Even if the vast majority of stuff I'm going to do is just buying modules that practically anybody can learn in a day or whatever. This voltage booster, it was that simple. So that's it. Thanks for watching. Make sure you check out one of the other videos I posted on the screen and check out the links down below. They all help out a lot. I'll see you in the next video.